Hello, everybody. First of all, I want to propose renaming this basin because it's hard to say. Um, so this is a familiar view of the south pole of the moon as if you're looking straight down at it, and you can see the candidate Artemis sites that we've heard so much about. We all know we're going there because of the permanently shadowed regions and the potential for volatiles. If I switch to a topographic view, we're also interested in the South Pole Aitken Basin, which shows up in the dark blue as a huge depression on the moon, the largest and oldest basin on the moon that we know of. It likely excavated the mantle, and that would be great because we could get a sample of the inside of the moon. It also gives us a foundational age date for every other event since then. Just for a moment, I want to draw attention to this feature, which is the Schrödinger impact basin. It's about 312 kilometers across. There's a distinct ring of mountains in the center. That is a great example of what's called a peak ring impact basin. These peak rings are thought to form by the uplift of material down to very great depths in the crust to the surface. So that's obviously a wonderful target for sampling to learn more about the interior of the crust. It's also right on the outer terrace of the South Pole Aitken Basin, which is a particularly interesting spot, but I don't want to talk about it. I want to talk about this basin, the Amundsen-Ganswindt Basin, which is, as you can see, in the same radial position as Schrödinger. It's older, much more degraded. And as you can clearly see here in this view with a topographic coloration, red being high elevation, blue being low. I just want to draw, I think I have a laser. Do I have a laser? No. I guess I don't. I want to draw attention to the top left where there's a big circular crater with a little mountain in the middle. That's Amundsen. If you draw your eye straight down from there, I hope that you can make out there's a slight semicircular trend right around what would be the center of the main degraded Amundsen-Ganswindt Basin. This particular feature is very interesting because if I overlay crustal thickness modeling from Zuber et al. Using Grail data, you can see that there's a thickening in the yellow colors just in the crust underneath that topographic trend, right? Encircling a central thinning of the crust, and that thinning is characteristic of peak ring basins. So I think it stands to reason that we have a preserved peak ring, and parts of it are within the sort of general Artemis exploration zone. I think that this is a possible explanation for why there's, right where the blue arrow is pointing, a higher rim of Schrödinger right there as opposed to sort of on either side of it. It might be because sort of some kind of constructive interference. But anyway, there's other stuff in the Amundsen-Ganswindt Basin of interest. If you look where that big red arrow is, I hope you can see the big red arrow. There's some red spots. There's others. These are spots where the M cubed moon mineralogy mapper was able to detect water ice. And I'm going to zoom in on that one with the arrow. So closer in now, I've put on some shape files from Landis et al. These are areas where water ice would be stable at the surface. That peak ring remnant is casting a shadow. It's permanent shadow there. So we have kilometer scale areas where water ice would be stable, and we have detections of it. We also have detected summer maximum temperatures where the blue, right where the white arrow is pointing, down to maximums as low as 70 K, not everywhere, but in some pixels. So that's interesting. This is an Imbrian aged crater. So the ejecta of it, if there's volatiles there on top of that ejecta, they must be more recent than the ejecta. So these are relatively more recent than some of the other PSR volatiles, like in maybe Cabeus or Faustini. So that might represent an interesting comparison point. As well, this crater is directly into that peak ring remnant I talked about. So it might, if the peak ring was completely buried by Schrödinger ejecta, which I can't say for sure, I don't know how deep the burial might be, there's a chance that this has excavated samples of this older peak ring to the surface for us. There are also lots of deposits that are very smooth. They embay hills and they infill topographic lows. They're very much like impact melt. I'm going to just call them impact melt for now. So these, quote, impact melt deposits are, I think, here I've mapped them across the basin. So I likely they came from Schrödinger, but I think another possible source is Amundsen. They would be a very interesting target. If there's any slight chance that there's melt from Amundsen-Ganswindt itself, that'd be a really cool comparison. It's possible that Amundsen-Ganswindt hit a more pristine South Pole Aitken Basin outer rim than did Schrödinger, which has incorporated part of Amundsen-Ganswindt itself. So bringing it all together, we have a geographic confluence of all these interesting targets of geology, and it just was quite a surprise that the proposed path for the Endurance rover mission concept just happens to go right by here. So I was like, thank you. That's great. If they want to just make a pit stop, I would be a very happy little master's student. Hopefully I'm not still a master's student by then. But anyway, in conclusion, I think Amundsen-Ganswindt has been overlooked. It does have a peak ring remnant still standing above the topography. And you can see there, if I just kind of define the Artemis exploration zone as bounding all of the Artemis III candidate sites, we have some of it there. And this peak ring may have uplifted deep crustal material of the South Pole Aitken Rim to the surface. And that little crater called Idelson that I zoomed in on may have actually uplifted it again after being buried by Schrodinger. We have large kilometer scale PSRs with well-supported ice detections, and those melt plains to the south of that area I zoomed in on lead up on a very gentle slope up to the PSR, meaning that access by a rover would be fairly realistic. And then again, those large impact melts themselves, which may possibly come from Schrodinger. So yeah, thank you very much for your time, and I'll be around later.